PSA Peugeot Citroën's Virtual Reality Centre is a place where people can immerse themselves in tomorrow's automotive world today. The centre features 3 systems that enable the designers of future group products to work inside the vehicle, practically as if it already existed. Cave Automatic Virtual Environment, Stereoscopic CAD Wall, Holobench. These 3 tools all provide Scale 1 3D visual perception using stereoscopic projection. They provide first-person simulations. Designers can put themselves in the place of a vehicle occupant or an operator at his or her workstation at the plant. The Cave Immersive Room consists of 5 projection screens. Inside the room, users wear glasses, giving them a 3D vision of the virtual scene they're immersed in. Using sensors placed on the user's glasses and body, graphic computers generate images in real time, projected according to the direction of the user's gaze to provide an interactive experience with the virtual world. Outside the cave room, the project team monitors operations, communicates with users, and provides input on solutions. This allows each of those involved to assess the projects using a hands-on approach as part of a team effort. The cave can be used in the following configurations: the sitting buck, the virtual dummy, collaborative mode. The cave features a sitting buck that can be adapted to all types of vehicle. The driving station is installed in the center of a virtual screen, showing the cabin and the exterior details, thus providing the necessary realism. Sitting in a real seat, users interact directly with the virtual vehicle. They operate the functional controls and change viewpoints inside and outside the cabin. This configuration is used to assess the vehicle's structural design, check visibility and ergonomics, and interact with all of the moving items in the passenger compartment. In this configuration, users are covered with movement sensors and perform assembly line maneuvers on a virtual production line. They try several different ways of fitting a rear bench, for example, while an ergonomist analyzes the movements necessary to the maneuver. The objective is to evaluate the feasibility of manual operations and optimize workstation ergonomics to reduce the arduous nature of certain tasks. Here, the design of large tooling whose cost prevents the production of prototypes is checked. Life-size virtual models are visualized in 3D to verify progress status, research hypothesis and kinematics in order to ensure product safety. The stereoscopic CAD wall is adapted to working group sessions. The virtual stage shows a Scale 1 vehicle in a realistic environment. Interaction with the virtual model is controlled from the control console. This configuration is used to compare vehicle architecture concepts, assess perceived quality, anticipate physical modeling, and in the long term, replace physical models. Experts are able to visualize calculation results, hear airflows inside the cabin, and thus share their findings with the entire project team, with the goal of improving thermal comfort for the customer. In a more active configuration, the stereoscopic CAD wall is coupled to an arm with force feedback to provide sensory immersion. Users manipulate an object in a virtual world, but feel the result of their actions through the perception sent back by the arm. This can be used to check, for example, the feasibility of assembly operations, even though no physical part exists yet. This immersive system with 2 projection screens is equipped with a force feedback interface, with the tool used by the operator maintained in a network of wires connected to motors. When the tool collides with an object in the virtual world, the wiring tightens and users feel this contact as they would in reality. The Holobench is used to verify the feasibility of manual operations on the assembly line or in the paint shop. Users feel the different levels of sheet metal and apply sealing mastic with a gun. This allows them to check the feasibility of the operation in terms of both visibility and ergonomics without a physical prototype. For assembly operations, users hold the part with an interactive hand, as if they were holding the object in physical space. Here, a user assesses the feasibility of fitting an engine component on the virtual model to check if the operation is easy to carry out. Today, these systems are used as a complement to physical models, or before physical models exist. But in the long term, most of the assessments currently made with physical resources are likely to be made virtually. Virtual reality is becoming an indispensable tool in automotive design. Here, you can touch the future.